Hello everyone, welcome back to my channel. In this video, I'll analyze a drying operation where hot air removes moisture from a wet solid. Let's understand how to calculate the moisture removed and the air circulation rate through the dryer. Here is the problem statement. A drying process removes water from 1200 kg per hour of wet solid materials. The moisture content decreases from 25% wet basis to 5% wet basis. Hot air flows through the dryer and entering at 80 degrees centigrade and exiting at 50 degrees centigrade. So here are the given data. So feed rate of the wet solid m dot feed, that is 1200 kg per hour. Initial moisture content in wet basis, that is W1 is equal to 25%, means is equal to 0.25. Final moisture content wet basis W2 5%, that is 0.05. Air inlet temperature, that T in 80 degrees centigrade. Air outlet temperature T out is equal to 50 degrees centigrade. Inlet air humidity H1 is equal to 0.0 kg of water by kg of dry air, and outlet air humidity H2, that is 0.04 kg water by kg dry air. Now here are the two objectives, means we have to calculate the mass of moisture removed from the solid, and second one, that determine the dry air circulation rate through the dryer. Now here is the process flow diagram. In that process flow diagram, air enters at 80 degrees centigrade with humidity H1 0.01. So air is entering and air is leaving with temperature 50 degrees centigrade with humidity 0.04 kg per hour. Now here the wet feed enters at kg per hour with moisture 25%. Now here we have to find out the kg of water and kg of solid, and here that we don't know how much dry air is flowing, and also we don't know how much moisture is removed, so we have to calculate that. And dry product, how much dry product we are getting, so that also we don't know right now. We have to calculate that. And in the dry product 5% moisture is there. We have to find out kg of water in the dry product and kg of solid in the dry product. Okay. So now before going to solve this problem, so first we have to define some keywords. So here is a key definition: moisture content in that wet basis. So that is moisture content on a wet basis is defined as W is equal to mass of water divided by total mass of wet material. So this is the wet basis moisture content. From this we can write mass of water is equal to W into total mass, just cross multiplication, and mass of dry solid will be 1 minus W into total mass. And another definition we have to remember, what is the absolute humidity? Absolute humidity or humidity ratio is mass of water vapor by mass of dry air. So we have to remember this definition, and based on that we will do mass balance on the solid phase, on dryer. Okay. So here I am calculating mass of dry solid. So here the dry solid mass remain constant throughout the drying process, only water is removed. So from that inlet stream we already know that mass of dry solid is equal to 1 minus W1 into m dot feed, that we got from the earlier the definition. So now here calculate dry solid mass. So air inlet at inlet wet feed, so mass of dry solid is equal to 1 minus 0.25 into 1200, so that is 0.75 into 1200, so 900 kg. So we got the dry solid, so 900 kg per hour. This 900 kg per hour of dry solid passes through the dryer unchanged. So this is fixed. And based on taking that, we will calculate other things. So next, step number 2, calculate water content in the feed and product. Okay, so here we already know that dry solid, so that is 900 kg per hour. Okay, so now from here we can calculate water in the feed inlet. So mass of water inlet is W1 into m dot feed. Okay, and water in product outlet. So first calculate the total mass of the product. So mass of the product will be mass of the dry solid divided by 1 minus W2. So mass of the water outlet W2 into mass of the product. Now we are going to calculate all this. So first calculate the water content. So water content will be that is m water in is equal to 0.25 into that is 1200, so 300 kg. So dry solid we got 900 kg and water is 300, so total is 1200 kg per hour. And total mass of the product, m product, so 900 dry by 1 minus 0.05, so that will be 947.37 kg per hour. So that is our product. Now here what will be the water? So we know that dry solid is that will not change. Dry solid is 900. So if you subtract, so we will get 47.37 kg per hour, or m water dot out. So you can multiply 0.05 into 947.37, we will get something. So dry solid is this and water is so 47.37. So total is in the product side that will be 947.37. So we got that. Now calculate the moisture removed. So m water removed means m water in minus m water out. So m water in means, so in is 300 and out is 47.37 kg per hour. So if I do that, we will get that. Okay, so that is there in the next step number 3. Okay, so again, so step number 3 is, so 300 minus 47.37, so that is 252.63 kg per hour. So the water is evaporated and carried out by the air stream, so that is 252.63 kg per hour. Now step 4, that material balance in air stream. So we have to calculate how much air is needed for this drying process. Now here, so the air picks up moisture as it passes through the dryer. We can write a water balance on the air. So water picked up by the air is equal to water removed from the solid. In terms of dry air mass flow rate, m dry air, and humidity, we can write m dry air into H2 minus H1 is equal to m water removed, because that humidity change into m dry air. Solving dry air circulation rate, so m dry air is equal to m water removed by H2 minus H1. So H2 minus H1, so H2 is, we already that H2 is given in the problem, and H1 is also given. So 0.04 minus 0.01, so that is 0.03 kg water by kg dry air. So we got that water content. So from that we will get the dry air circulation rate is, so water by 0.03, that is del H. So that is 8421 kg per hour. So that is m dry air. This means 8421 kg per hour of dry air must circulate through the dryer to remove the required moisture. Now we have to do the verification. So step 5 is the verification and additional calculation. So here we have to calculate first total air flow rate. So inlet air, humid air entering. So m air in, m dry air 1 plus H1, and m air out, m dry air into 1 plus H2. So here first we are calculating humid air entered the dryer. So dry air is 8421 plus 1 plus 0.1, so that is 8505.21 kg per hour. Humid air leaving the dryer, so 8421 into 1 plus 0.04, so that is 8757.84. Now verification means increase air in the mass, del m air is, so that is 252.63, that is nothing but moisture. Okay, so that we can easily verify that things. Okay, so that matches the moisture moved from the solid. Now here is the process flow summary full. So we got all this information. So from here, that wet feed, so that is 1200 kg per hour, 25% moisture. So from there we can easily calculate 300 kg per kg water, 900 kg per solid per hour. And in the dry product, so we got that 947.37 kg per hour, 5% moisture. So from there we can easily calculate 47.37 kg per water and 900 kg of solid. So solid can't be changed, it will be same throughout the process. So you can see here and here. And then air in 80 degrees centigrade, humidity of the air inlet is 0.01, air out 50 degrees centigrade, H2 is 0.04. So here that circulation rate is including the water 8505.21 kg per hour and 8757.84 kg per hour. So moisture removed means moisture added to the air is 252.63. So moisture removed 252.63 kg per hour, that will pick up by the air. Now here the final summary. Final summary is here. So dry solid 900 kg per hour, water in feed 300 kg per hour, water in product 47.37 kg per hour, moisture removed 252.63 kg per hour, change in humidity del is 0.03 kg water per kg dry air circulation rate 8421 kg per hour, humid air inlet is 8505.21 kg per hour and humid air outlet is 8757.84. So that's it. Thank you.